In this LS H100 inverter video, we'll cover the speed command loss function. So what does this feature mean? For a practical example, let us say you have selected your primary frequency reference through the analog current input terminal. In this scenario, you have connected a standard 2-wire 4 to 20 milliamp sensor directly to the H100 series inverter, and based specifically on the gradual increase or the decrease of this milliamp signal, the H100 inverter automatically controls the rotational speed of your electric motor to match the required output. If this specific 2-wire analog sensor of yours suddenly gets disconnected from the system, the inverter needs a way to respond. How exactly should it detect that your critical analog input signal is now completely disconnected and that one of the individual sensor wires has been accidentally cut, chewed by rodents, or otherwise broken somewhere along the way? In what way does the inverter monitor these electrical connections to ensure that it can identify a fault immediately when the circuit is interrupted? Find it necessary to detect this condition? In order for the system to detect this capability, we need to enable and activate the speed command loss feature within the H100 series inverter. So how do we do this? If you navigate your way to parameter PRT12 in the H100 inverter, specifically in the protection parameter group or PRT, the specific parameter numbered as 12, you will find the available speed command loss operation mode option. Within the settings for this specific parameter, you need to activate speed command loss. This feature provides several different configuration options. The first option for this parameter is none, which is set to 0. This means you don't want to activate this feature at this time. The second available option is free run. If you choose to select this specific option, the inverter, as soon as, based on the settings you've made, if it detects a command loss of the input signal, the inverter output will go into free run mode and your electric motor will gradually begin to come to a stop based on its own inertia. But if you set it to the next option, which is DEC, when the inverter detects a command loss according to the time based on the specific deceleration time that you have successfully configured and established in PR07, or the trip deceleration time, it will then initiate the process of decelerating and stopping the connected electric motor system. However, if you choose to configure the settings using the third available option, which is labeled as hold input, and we look at the detailed technical specifications provided within the manual, in this mode, the inverter unit will automatically perform a calculation of the average input value based on data from the 10-second window that occurs immediately prior to the moment the command loss occurs. And it establishes that specific value as the primary speed reference point, and the inverter system begins its operation at that exact frequency to ensure it matches the necessary system parameters. But if you specifically choose to select the fourth option, named Hold Output, the system automatically calculates the mathematical average over a full 10-second time interval based on the produced output value generated by the process. That is to say, the system continuously calculates the specific output value and then once again sets it as the primary speed reference for the inverter, and consequently your inverter operates steadily at that precise average value throughout the entire process. However, if you decide to specifically select the last per set option from the menu, the system will operate according to the precise numerical value that you have manually set in the PR14 configuration field located right here on the interface, ensuring the data remains consistent with your latest saved settings. The system begins its operation cycle. So if you configure this specific setting to option number 5, which is the last preset, and set PRT14 to, for example, set it to 10 Hz, immediately at the moment when the last command occurs, your inverter will operate at the exact frequency value that you have established in this parameter. This essentially means that it will run at 10 Hz. But there are several additional configuration parameters you need to set for this feature, and a particularly important one to note is PRT13. It specifies last command time, which determines exactly how much time the system should wait before giving us the last command signal or error. Here, you can easily set that specific time. But when we look at parameter PRT15, which is the analog input last level setting, you will see that there are actually two different options available here. The first option provided is half of x1, and the other available choice is x1 itself. So as you can see, we have these two specific options to choose from for this setting. One of the experienced technicians thoroughly explains the configuration process. If you carefully set the specific initial reference point for the various different analog inputs located on the frequency inverter control unit and the Saichu, I will consider exactly 50% of that specific value. And if 50% of that value is detected within the system, I will officially conclude and determine that your power inverter has been lost or disconnected. It has been commanded, or perhaps your analog input has been disconnected. For example, on the inverter, you can set two specific points on the analog inputs. For example, we would say at 4 milliamps, the frequency is 0, and at 20 milliamps, the frequency is 50. That lower point, 4 milliamps, becomes the X1 point. It says half of that is 2 milliamps. If that happens, meaning it goes below half of 4 milliamps, which is exactly 2, so if it drops below 2 milliamps, I detect that a lost command error has occurred, and the output is immediately cut off from the system. There's another option called priority 15, which says no. If the specific threshold value you have set in X1 is that standard level of exactly 4 milliamps, as soon as it falls significantly underneath that 4 milliamps mark, I will immediately identify the lost command error and determine that your analog current input wire is probably disconnected from the system, and the inverter should cut the output power entirely to ensure safety. You can also take advantage of the inverter's integrated output signaling relays to effectively identify and detect the lost command signal. To configure one of the inverter's relays from 1 to 5, you need to enter the out parameter group. If you set any of the relays from out 31 to out 35 to number 13, as soon as a lost command occurs, one of the inverter's relays will be activated for you. If you would also like to properly configure the transistor output, specifically out 36, which is the transistor output Q1, set it to number 13. You need to configure it so that when a lost command occurs, your transistor output is activated. But the example we want to work on together in these tutorial videos is that we want to set out 31, which is relay 1 of the inverter, to number 13, meaning that a lost command will trigger a signal lamp. We want to establish a physical connection for this inverter to the A1C1 terminals, so that if the inverter specifically gives a lost command error, this visual indicator signal lamp will automatically illuminate and turn on for us. By carefully following the wiring you see in the diagram, let's systematically apply every single one of the configuration settings we have learned for the speed loss command on this H100 inverter, and thoroughly test out the functionality of this specific feature together. As we have previously discussed in LP, in order to enable and activate the loss command functionality on the PowerFlex H100 series inverter, we need to enter the PRT parameter group, which is the protection group. The protection parameter group is located in parameter PRT 12. We need to carefully define and specify exactly what action the inverter should take if a lost command error occurs. I have set it to the free run stop option, meaning I will let the output free run to a stop. I set this in PRT 13. I specify how many seconds it should wait before giving me the lost command error. So for example, I set the time to 3 seconds. In PRT 14, we previously mentioned that if we specifically set the PRT 12 parameter to a value of 5, and that event happens, at what exact frequency should the inverter operate? Here, since we have already set it to the free run mode, which essentially means the output will be completely disconnected, we actually do not need to configure the PRT 14 parameter at all. Okay, moving on to PRT 15, we said that we can carefully consider two different operational modes. The first operational mode specifies that if the original reference point you used or set for the analog input decreases to less than 50% of that value, the system will trigger a loss of command signal error. For example, half of 4 milliamps is 2, so if it goes below 2 milliamps, I have detected the loss command error. The second option indicates a negative response. I'll use the exact specific value you defined for the current at X1, the first analog input point. If it drops below that value, I detect the loss command error. I set it to the second option, which is X1. As soon as it goes below 4 milliamps, the inverter gives a loss command error. I confirm it. Right now I'm going to the IN group. Let me check my analog current input value. Okay. Now if you look at the display, you can see that I have 6.8 milliamps at my input. Should I start the inverter? Okay, the inverter begins to operate, and I gradually increase my analog current input signal value. Okay, now if I proceed to open my analog current input settings, or rather specifically monitor my analog current input signal, if the measured value of this signal drops below the threshold of 4 milliamps, the inverter system automatically detects a loss of command error and immediately cuts off the power to the output for safety. I gradually lower the analog input signal, and as soon as it drops below the 4 milliamp threshold, the inverter immediately triggers a speed loss command error message and completely cuts off the power output. It waits for 3 seconds, and after 3 seconds it triggers the loss error. It effectively gives the specific command and then immediately activates the relay that I have previously defined for the loss command. We mentioned earlier that in order to properly define the relay settings, we first need to enter the OU parameter group, or in other words, the OUT group, specifically looking at parameter 31, which is directly related to the first relay. We can then manually set it to the loss command mode, and finally exit the menu system to ensure all settings are saved correctly. Now, if the loss command error happens again, my relay number 1 is now successfully activated. You can clearly see that it gave the loss of command error message, and since I had previously set relay 1 to the loss of command mode, relay 1 was immediately triggered as expected. Alright, now when the primary input signal wire to my inverter, which is my analog input, becomes accidentally disconnected, my inverter, since it drops below 4 milliamps of the signal, it will automatically trigger and display the loss command error. It detects and recognizes that my analog current input wire has been disconnected. I'm going to open this, the related input. I'm disconnecting the current analog input, I2. Look, as soon as I disconnect it, after about 3 seconds, the inverter gives the loss command error. So in this instructional video, we got familiar with the loss command feature in this inverter, right?